Okay, so guys, today we'll be discussing organizing and visualizing data. Now, the purpose of today's discussion is to understand the impact of extreme events, the impact of outliers on investment returns, the impact of extreme events on stock returns. And significant events such as the global pandemic, significant events such as political events can cause stock returns to deviate from what they were in the past. And these stock returns, these outlying events, these extreme events can have a significant impact on the average returns of a particular investment, on the average returns of a particular stock. They will obviously naturally increase the variability of returns as well. So, in today's discussion, we would understand what would be an appropriate measure to calculate average returns in the presence of outliers, in the presence of extreme events. Okay. So, guys, how do we calculate average returns? Okay. So, guys, average return is nothing but the mean, and in our particular syllabus, there are four ways to calculate the mean, right? There are four ways in which we can calculate mean. The first is your arithmetic mean. Next is your weighted mean. Third is geometric mean. Last is your harmonic mean. There are other means as well, such as vincerized mean and trimmed mean. That is something that we will discuss tomorrow. But today we are going to discuss these four types of means in detail, right? And our discussion is basically how extreme events, how outliers would affect each of these mean measures, right? How outliers would affect arithmetic mean, how outliers would affect the geometric mean, how outliers would affect the harmonic mean. So let's start our discussion with arithmetic mean, right? This is something that we've already done in school, right? But today we are going to have a deeper look into the arithmetic mean, right? So arithmetic mean is nothing but an average. And how do you calculate the arithmetic mean? It's the sum of observations divided by the number of observations. So your arithmetic mean denoted by x bar equals x1 plus x2 up till xn by n, where n is the number of observations. So you sum up the observations and you divided by the number of observations. That would give you the arithmetic mean, and that is the average, right? This is the average return. That is where your observations are centered. Okay guys, so let us say that we have four observations in a distribution, right? So we have a series of stock returns: 2015, 16, 17, 18, right? Stock return in 15 is 8%, 16 is 5, 17 is 4, 18 is 3. Okay, so guys, what would be my average return? What would be the average return here, guys? My average return would be,
5.
return would be 8 plus 5, 13, 13 plus 4, 17 plus 3, 20, 20 divided by 4, that is 5%, right? And guys, before I discuss further, please understand the difference between an observation and a distribution, right? I'll be using this term over and over again. I'll be using the term observation as well as distribution. When I say an observation, this 8% is an observation, this 5% is a observation, but all these four observations collectively are my distribution, right? So a series of observations is a distribution. This 8% individually is an observation, this 5% individually is an observation, but these four observations collectively together are a distribution. So a distribution is a series of observations. Okay. So the arithmetic mean of these four observations is 5%, right? But the average stock return over this 4-year period is 5%. Okay, so this is very easy, simple to calculate, nothing gung-ho about it. But now we'll dig deeper into the subject matter. Now, the first very important characteristic of arithmetic mean is, please write this down, guys. The first very important characteristic of arithmetic mean is that the sum of deviations around the arithmetic mean, sum of deviations around arithmetic mean denoted by x bar am is 0. Right, so what I'm trying to say here is x1 minus x bar plus x2 minus x bar plus x3 minus x bar up till xn minus x bar is going to be 0. Right, so sum of deviations around the arithmetic mean is going to be 0. So guys, let us calculate the deviations around the arithmetic mean in this particular data set, x minus x bar. So x minus x bar is going to be 8 minus 5, which is 3. 5 minus 5, that is 0. 4 minus 5, that is minus 1. Right? And 3 minus 5, that is minus 2. You add the deviations, how much do you get? You'll get 0. Right, you get 0. You can see that the negative deviations are cancelling out the positive deviations. So the sum of deviations around the arithmetic mean always equals 0. Now this particular property shall hold good for any distribution, right? It shall hold good for any distribution. Right guys, are we good here? Can you see that the negative deviations are cancelling out the positive deviations? Are we good, yes or no? Yes or no, guys? Please tell me.
Good, sir.
Okay. However, guys, sum of deviations add up to 0 only in case of arithmetic mean, not in case of geometric mean, not in case of harmonic mean. Please note this down. Sum of deviations around the arithmetic mean and the arithmetic mean only would add up to 0, not in case of harmonic, geometric, or weighted mean. Right? So this particular property pertains or is exclusive only for your arithmetic mean. The next property of arithmetic mean is that it is affected by outliers. Okay, so guys, outliers, as I said, are extreme values that are much higher or lower than other values in the distribution, and outliers affect the arithmetic mean. So if the distribution has a positive outlier, that is an extremely high value, then arithmetic mean will be pulled upwards, and this will look as if the distribution had a very high average. Conversely, if the distribution contains a negative outlier, that would mean that the arithmetic mean would be pulled downwards, making it appear that the distribution has a lower average value. Right. So, guys, say understand this with an example. Say there is a stock 2015, it gave a return of 1%, 16 it gave a return of 2, 17 it gave a return of 3, 18 it gave a return of 4, 19 it gave a return of 5, 20 it gave a return of 100%. Guys, what is the arithmetic mean of this particular series of stock returns? Please calculate the arithmetic mean.
19.16.
19.16. Right, guys. So 19.16%. So majority of the returns are between 1 to 5. But AM is making it look as if stock returns are high when they are actually not. Right, guys? Majority of the returns are between 1% and 5%. But the AM is making it look as if stock returns are high when they are actually not. Why is this happening, guys? Why is this happening? Please tell me. Why is this happening?
Because of the
Outliers
outliers.
pulling the
Yes, because presence of
arithmetic
this
mean
extreme
towards it.
outlier value of 100% greatly skews or greatly pulls the mean upwards, making it look as if that stock returns are much higher than they actually are. And in such a scenario, guys, in the presence of outliers, arithmetic mean is not reliable, right? It's not a reliable measure. Median may provide, right? We are going to discuss median later on. Median may provide a better representation of data set in the presence of outliers, right? Median would provide a more better representation of data set in the presence of outliers. Guys, this 19.17 is not a good representation of this data set because majority of the returns are between 1% to 5%, right? And the arithmetic mean is if you look at the arithmetic mean, if you look at the arithmetic mean, you will falsely believe that the average returns are higher when they are actually not. So, in arithmetic mean is greatly affected by outliers, right? And it's not so reliable in the presence of it, right? Are we good, guys? Have we understood this point? Yes or no? Should I move forward, or do you have any doubts?
No, sir.
Yes. Okay.
Good, sir.
Now, when we calculate the arithmetic mean, we give equal weight to each observation. We give equal weight, right? So, guys, in this particular case, um, there are 4 observations in this particular distribution, and we give each observation a weight of an equal weight of 1 by n. So there are 4 observations. So we give each observations a weight of 1 by 4, that is 0.25. Now, guys, calculate the arithmetic mean by giving a weight of 0.25 to each of these observations. Tell me how much do you get? You must get 5%. Give a weight of 0.25 to 8, 0.25 to 5, 0.25 to 4, 0.25 to 3. You'll see that the arithmetic mean is 5%. Please do this. Now, please do this like really fast.
Yes, sir.
So you will be getting 5%. So arithmetic mean is giving equal weight to each observation, right? Okay, but guys, what if we wish to assign separate weights to observations? Then what should we use if we wish to assign separate weights?
Weighted mean.
Yes, in such a situation, we would use weighted mean. Okay, so weighted mean assigns separate weights to observations. So, say there is a portfolio manager who invests 60% of his funds in stocks and 40% of his funds in bonds, and the average return of stocks is 10%, average return of bonds is 8%. So what is the average return of his portfolio? The average return of his portfolio is going to be weight of stock into return of stock plus weight of bond into return of bond, which is going to be 0.6 into 10 plus 0.4 into 8. That is how much? 10 into this is 6, this is 3.2, so 9.2%. Right, this is nothing but your weighted mean. Are we good here, guys? Any doubts? Yes or no, please tell me.
No, sir.
Good, sir.
Then we use geometric mean. Now this is a bit important, pay a lot of attention here. Okay, now guys, we've discussed EM and GM, right? When we calculated the arithmetic mean, we added up all the observations and divided it by the number of observations. In case of geometric mean, we multiply the observations and take the nth root of the product, right? So how we'll calculate the geometric mean? X1 into x2 into x3 up till xn, and we'll take the nth root of this product. This is my geometric mean. But for calculating geometric mean, guys, x1 should be greater than 0, x2 should be greater than 0. That is, x1, x2, x3 up till xn should be greater than 0. That basically means that the observations in the distribution should be positive. They cannot be negative. Why, guys? Why? Please tell me. Why can't they be negative? Guys, why can't they be negative? Please tell me. Okay. So, guys, what is the root of a negative number? What is the square root of a negative number? Calculate the square root of
Imaginary.
minus 10 in your calculator. Tell me what you get. You will get an error.
Undefined.
Huh? Yes, undefined.
Undefined.
Yes, so the square root or root of a negative number is imaginary. Right. So in the presence of negative numbers, there would be no GM for a particular distribution. If a distribution has negative numbers, its GM would be imaginary. That is, its GM would be meaningless. Right. That is why for calculating the geometric mean, we should have a distribution with positive observations only. There should not be any negative observations. Guys, but stock returns can be negative. Guys, stock returns can be negative. Yes or no? Please tell me.
Yes.
So how to calculate the GM of stock returns?
1 minus 1 minus the
Okay,
again.
so what we do is, guys, calculate the GM. Okay, say returns in 2019 are 10%, 2020 is minus 6%. Now, if you would calculate the GM of these two numbers using in the traditional way, what you will do is 10 into minus 6. How much is this? 10 in, take the calculate the square root of 10 into minus 6. How much do you get?
Not
Or
defined.
it should be zero point 0.1 into 0.06. 0.10 into minus 0.06. How much do you get? Please tell me. It would be an imaginary number, right? It would be giving you an error. Guys, are you seeing an error in your calculator? Yes or no?
Yes, sir.
So this GM is meaningless. Now, how to overcome this? How to overcome this problem? Now, what you do is,
1 plus point 1.
yes, you add 1 to each observation under the root and deduct 1 outside the root. So what you're going to do is, you add 1 to each observation under the root and deduct 1 outside the root. So now calculate the GM, guys. How much do you get? Please calculate this. This is how much? 1.1 into 0.94 minus 1. Right? Multiply 1.1 with 0.94. Take the square root of that and deduct 1. Let me know how much do you get. Chalo, please let's do this like really fast. बोलो
1.68.
कितना
1.68%.
1.1 into 0.94 1.034 yeah,
1.0168.
it's going to be 1.68%. Yes, 1.68%. Okay, very good. So this would be the geometric mean. So guys, in an investment setting, we calculate, or when we need to calculate the geometric mean of stock returns, we do it in this fashion. Right. So this is how we calculate the geometric mean of stock returns. Right? This is how we were taught to calculate the geometric mean in school. Take the product and take the root of the product. But this is how we will calculate the geometric mean of stock returns, because the stock returns can be negative. Guys, are we good here? Any doubts?
No, sir.
Yes or no? Okay. Now, guys, let's do this. 1, 2, 3, 4, 5, 6, 100. 1000. Now I'll calculate the arithmetic mean of this, guys. I'll calculate the arithmetic mean of this. Arithmetic mean of this data is 145.85. Right, so it's not representing the data set appropriately because majority of the observations are between 1 to 6, but the extreme value of 1000 is pulling the mean towards itself. That is why the arithmetic mean is 145.85. Now I'll calculate the GM. So guys, what is the GM? Guys, how much is the GM?
6.8.
So can I say, is the GM a more is GM a better representation of the distribution, guys? Yes or no, compared to your arithmetic mean?
Yes, sir.
Yes, sir.
Yes, it's a better representation of your distribution. Or can I say that the effect of outliers on geometric mean is less than that of arithmetic mean? Can I say that?
Yes,
Yes
sir.
or no? Yes.
Yes, sir.
Right. So in any of these cases, we'll see that the effect of outliers on geometric mean is less than the impact of outliers on the arithmetic mean, right? So we'll write this down here. Geometric mean is less sensitive to outliers compared to the arithmetic mean, or the effect of outliers on GM is less than that of AM. Or you could also write that GM is less sensitive to outliers compared to AM. GM is less sensitive to outliers compared to AM. This is an important point, guys. Please note this down. Okay. Another very important point, guys, that uh, we use the geometric mean to calculate the average return over multiple time periods, right? We use the geometric mean to calculate returns over multiple time periods. So basically, GM is a more superior method than AM when we need to calculate returns over multiple years. So let's see how. So say you bought a stock at time 0 at 300. At the end of year 1, the stock price appreciated to 600, and the end of year 2, the stock price again fell to 300. Okay. So guys, what is the arithmetic mean of returns for the first year? It's 600 minus 300 by 300. That is 100%, right? That is 100% arithmetic mean of returns for the first year. And arithmetic mean, okay, not arithmetic mean, return for the first year. Sorry. A return for the first year is 100%, and return for the second year is 300 minus 600 by 600 into 100. That is minus 50%, right? So the return for the first year is 100%. The return for the second year is minus 50%. Now guys, calculate the arithmetic mean of returns. Please calculate the arithmetic mean of returns. What is the arithmetic mean?
25.
The
25.
arithmetic mean of returns is 25%. Is this arithmetic mean a true representation of what I've actually earned over the 2-year period? Guys, is
No,
this,
sir.
have I earned anything? I
No, sir.
bought the stock at 300, and at the end of the second year, the stock price has not appreciated by a single dollar, by a single rupee. It's still the same 300. So I want nothing over this 2-year period, right? So my $300 investment in this particular stock is still equals what I had. I have not earned anything, right? I have not earned anything over this 2 year period. My $300 investment is still $300. But my arithmetic mean is telling me that I have made a 25% return on an average, which is not correct, right? So my arithmetic mean does not provide the true picture of average returns over multiple time periods. Now guys, calculate the geometric mean. Please calculate the geometric mean. So arithmetic mean is not giving a true picture. Arithmetic mean is telling me that I have earned 25% where I have earned nothing. Now we'll calculate the geometric mean. So how do we calculate the geometric mean? It's going to be 1 plus 1. 100% basically is 1 into 1 minus 0.5 minus 1. How much do you get? 2 into zero
0.
point 0.5? 0. So my geometric mean is 0. Is my geometric mean giving a true picture of what I've actually earned over the 2 year period?
Yes.
So we earned nothing over the 2 year period, and my geometric mean is telling you that only that you've earned nothing. You are stupid person. You have not earned anything, and geometric mean is telling you the truth on your face. So it gives a true picture of the average return over multiple time period, right? So when you have to calculate average returns over multiple years over multiple time periods, then one should use the GM, because the GM captures how returns are linked over time, right? So please note this down as well. Please write this down. If you want to calculate average returns over multiple years, over multiple time periods, then you should use the geometric mean and not the arithmetic mean. Okay, so the idea is that geometric mean is less sensitive to outliers than your arithmetic mean. The second idea is that if you want to calculate average returns over multiple years, you should use the geometric mean rather than the arithmetic mean. Are we good here, guys? Any doubts? Yes or no? Bolo.
No. Good, sir.
Right? Okay. Guys, next point, please write your geometric mean is always less than your arithmetic mean. Geometric mean will always be less than your arithmetic mean. Look at this case. Arithmetic mean is 25%, geometric mean is 0. Right? The one we calculated in the Excel here, arithmetic mean is 47, geometric mean is 8.7. So your geometric mean is always going to be less than your arithmetic mean. This is a mathematical property. Only one case, there's going to be only one situation when GM is going to be equal to AM. What is that scenario? Under only
All
one and one
observations are
circumstance.
equal.
Yes. So if all the observations in a particular distribution are equal, then we are going to see that the GM is equal to AM. So if I force all observations to be the same, we can see that my arithmetic mean and my GM is equal. So please write this down as well. If all observations are equal, then GM is equal to AM. One more property, guys, please write this down as well. GM is approximately equal to AM minus 1 by 2 into variance. GM, geometric mean of a distribution, is approximately equal to the arithmetic mean of that distribution minus 1 by 2 into variance. Variance is the dispersion around the mean, and this is something that I'll discuss in the next class. Variation is basically the dispersion around the mean. It's a measure of dispersion. Okay, so these are the things that you need to know about geometric mean, right? So first, uh, GM is less than AM. GM is always less than AM only under one circumstance. GM equals EM when, and that circumstance is if all the observations in the distribution are equal. And GM is approximately equal to arithmetic mean minus 1 by 2 into variance. Okay, then GM is less sensitive to outliers. Arithmetic mean is more, right? Next, we use GM to calculate average returns over multiple time periods. Okay, now guys, we've discussed all the properties of GM. Now we'll discuss harmonic mean. Do you have any doubts up till now, guys? बोलो किसी के कोई doubt है? Guys, is
No,
anybody having any
no,
kind
sir.
of doubt? Okay. Now we discuss the next method is harmonic mean. Okay, so let me take a sip of water before I discuss this. Okay, harmonic mean. Now harmonic mean is something that confuses a lot, but I am going to discuss the harmonic mean in very great depth. Now harmonic mean is an average which is calculated by dividing the number of observations by the reciprocal of each observation, right? So the harmonic mean is number of observations divided by the reciprocal of each observation. Okay, okay guys, and the idea here is that all the observations in the distribution should be positive, right? uh, all the observations in the distribution should be positive for calculating the harmonic mean. If observations are negative, then we can't calculate the harmonic mean, or then it does not make sense to calculate the harmonic mean. The reason behind this I'll tell you later when I have explained the harmonic mean, right? So your observations need to be positive, they need to be greater than 0 for you to calculate the harmonic mean. If observations, if there is a mix of negative and positive numbers, then calculating the harmonic mean is of no use. How? I'll tell you later. Okay, so calculate the harmonic mean of guys, calculate the harmonic mean of 1, 2 and 3. How do you do that? Harmonic mean of 1, 2 and 3. So let's get an idea. So harmonic mean is going to be number of observations, that is 3, divided by reciprocal of each observation. So reciprocal of 1 is going to be 1 by 1, reciprocal of 2 is going to be 1 by 2, reciprocal of 3 is going to be 1 by 3. So how much do you get, guys? How much is the harmonic mean? So 3 divided by 1,
1.64.
0.5 plus 0.33. कितना आया संतोष? 1 point
1.83.
हाँ 3
1 point
divided
Overall,
3
2.
divided by 1.83. How much is that?
1.64.
1.6.
1.64.
1.64. So the harmonic mean is 1.64. Now guys, what is the biggest advantage of harmonic mean? The biggest advantage of harmonic mean is that it is least sensitive to outlier. Out of arithmetic mean, geometric mean and harmonic mean is the least sensitive to outliers. So do this. Out of HM, AM and GM, harmonic mean is least sensitive. Okay, now guys, calculate the arithmetic mean of 1, 2, 3, 4, 5, 6 and 1000. Please calculate the harmonic mean and arithmetic mean. So let's do this in Excel, that will save us a lot of time. Okay, you don't do this, you can calculate this later. I'll do this 1, 2, 3, 4, 5, 6. 1000. AM is 145, GM is 6.86, and harmonic mean is, let's calculate the harmonic mean. Harmonic mean is 2.85. So guys, we can see that the harmonic mean is least sensitive. The outlier of 1000 is not being able to pull the harmonic mean towards itself. It's being able to pull the arithmetic mean, but it's not being able to pull the harmonic mean. Why is it so, guys?
So because the outlier, when it goes in the denominator, it will become very less.
Oh, beauty. Okay, so the idea is, guys, why is this happening? Please understand. Why do outliers pull arithmetic mean and not the harmonic mean? The reason is that arithmetic mean gives equal weight to each observation. But guys, harmonic mean gives a larger weight to smaller observation and a smaller weight to a larger observation. Let's see how does this happen. Right? Let's see this what happens. So the harmonic mean is giving a larger weight to a smaller observation and a smaller weight to a larger observation. So let's see how this happens. Okay. So first you calculate the reciprocal of each of the observations. So reciprocal of 1 is going to be 1 by 1. Similarly, you can uh, calculate all the reciprocals. Okay, then you calculate the sum of these reciprocals. Okay, now guys, you calculate the weight. How will you calculate the weight? Reciprocal by sum of reciprocal. Now you got to freeze this up, right? Okay, so we've had the weights. Now we'll multiply with the weight with the reciprocal or weight with the observation, right? So let's do that. Weight into the observation. So weight into the observation. The observation is 1. Okay. And then you sum up the weight into observation, you'll get the harmonic mean. Okay, so this is your harmonic mean 2.85. This here is your, let's see, yeah. This is your harmonic mean, right? So this is how the calculation works in the background. Right, so guys, you can clearly see that the weight given to the smaller observation is higher compared to the weight given to the larger observation. Now weight given to the smallest observation 1 is 0.407, which is the highest, and weight given to larger observations progressively reduce with the smallest weight of 0.000408 given to the largest observation of 1000, right? This smallest weight is given to the largest observation. Guys, are we good? Have you understood this? Yes or no? Have you understood the calculation, guys?
Yes, sir.
And the contribution of each observation to the harmonic mean is same, guys. Look at this. Contribution of 1 towards the calculation of harmonic mean is 0.407. Contribution of 2 is also the same, 3 is also the same, 1000 is also the same. So the weight given to the largest observation is small and the vice versa. Weight given to the smallest observation is the highest. Are we good, guys? Yes or no? Please tell me. Is this concept crystal clear or do we have doubts?
Clear, sir.
ध्वनि ये क्लियर है? अंकित, अनमोल, सुप्रतीक, सैयद, ध्वनि.
Yes, sir. Clear.
Good, sir.
So this is how HM is least sensitive of all the measures that we've discussed today, right? Because it's giving the least weight to the outlier, right? It's giving the lowest weight to the outlier, right? The outlier in this case was 1000. HM is giving the lowest weight to the outlier, and since it's giving the lowest weight to the outlier, it is the least sensitive of all the measures that we've discussed today. Okay, guys, now the next thing. Now, HM is used to calculate the average purchase price when you invest equal amount every period in a mutual fund. So, it will help you calculate the average purchase price of mutual fund units when you do a systematic investment plan, right? So, let's do this as well. Now, suppose guys, you invest 1,000 dollars every month in a mutual fund, right? So, in January, you invested $1,000, and the price at which you purchased your mutual fund units was 10. In February too, you purchased 1,000 units. You purchased mutual funds of $1,000, and the price at which you purchased them was 15. Right. So in January you purchased mutual funds worth $1,000 at a price of 10, and in February you purchased mutual funds worth $1,000 at a price of 15. Now we need to calculate the average price you paid per unit, right? The average price you paid to buy every unit of that mutual fund, right? So how do you do that, guys? Guys, what would be the number of units purchased in the month of January? Number of units
100 units.
purchased with $1,000
100
in
units.
Jan is going to be 1000 by 10, which is 100. And number of units purchased with $1,000 in Feb is going to be
67.
1000 by 15, which is 66.67. So total units purchased with $2,000 is 166.67, right? So with $2,000 you were able to purchase 166.67. So what is the average purchase price, guys? With $2,000 you were able to purchase 166.67. So your average purchase price is 2000 by 166.67. How much is that? Please calculate. With $2,000
12.
you,
12, sir.
yes. So the average purchase price that you paid to buy these 166.67 unit is $12. Now guys, this $12 is incidentally the harmonic mean of the purchase price. The harmonic mean of these two numbers is also going to be 12, right? So calculate the harmonic mean. 2 by 1 plus 10 by 1 plus 2 by 1 plus 2 by 1 by 10 plus 1 by 15. How much is this? 2 by 1 by 10 plus 1 by 15, you are going to get 12. Okay guys, are you getting 12? Please calculate this.
Yes, sir.
But you won't get 12 if you use the arithmetic mean. Arithmetic mean of these two numbers is going to be 10 plus 15. 10 plus 15 by 2, that is 12.5, and the geometric mean is going to be somewhere between these two numbers. It's going to be between 12.5 and 12. Calculate the geometric mean, guys. Calculate the square root of 150. How much do you get, guys?
12.24.
Yes. So your geometric mean is 12.24. So your arithmetic mean and your geometric mean won't give you this result. So the use of harmonic mean is more appropriate to calculate the average purchase price when you invest equal dollar amounts in a financial asset every month. Please note this down. HM, use of HM is more appropriate when you invest equal dollar amounts in a financial asset every month or every period. But guys, note, if you invest varying amounts every month, then you know, then you cannot use the harmonic mean to calculate the average purchase price. It's only when you use equal amounts, when you invest equal dollar amounts every month, it's only then that you can use the harmonic mean to calculate the average purchase price. But if you're investing varying amounts, right? So if in the first month you are investing $1,000, in the next month you are investing 2,000 or 3,000, then you can't use the harmonic mean to calculate the average purchase price paid. It's only when you invest equal dollar amounts every period can you use the harmonic mean to calculate the average purchase price. Okay. Now, guys, relationship between AM, HM, and GM. So, guys, please note your harmonic mean is always less than your geometric mean, which is always less than the arithmetic mean. This is usually the case. It's only under one scenario when HM equals GM equals AM. Under what circumstance your HM is equal to your GM is equal to AM? Please tell me.
Sum of all observations are
When all observations are equal, not some, but
some,
when
sorry,
all.
all.
Well, all the observations in the distribution are the same. There is no variability in observations. When all observations in distribution are same, that is when there is no variability. So let's look at this in the Excel. Uh, okay, so let's have let's have all the distributions to be 5. So guys, when all the observations in the distribution are the same, that is they are 5, then my AM equal GM equal HM. However, if even one is different, guys, then HM is less than GM is less than AM. Guys, are we good? Even if one is different, harmonic mean is less than the geometric mean is less than the arithmetic mean. Can you see this, guys, please? Yes or no? Please. Are we good here? Yes or no, guys? Please tell me.
Yes.
So can you repeat once, please? अटक
क्या?
रहा था यहाँ पे।
कौन सा कौन सा?
तो कुछ आप किया था क्या इसमें?
मैं कह रहा था कि if all the observations are the same, then AM equal GM equal HM. ठीक है ना? When all the observations are the same, Supratik, देख, then AM equal GM equals HM. But if even if one observation is different, then CHM is less than GM is less than AM. ठीक है ना?
Got it.
When all are same, then AM equal GM equal HM. But even if one is different, then HM is less than GM is less than AM. ठीक है, Supratik? Are we good?
हाँ हाँ
Okay. And guys, the mathematical relationship between GM, HM, and AM is that GM square is equal to HM into AM. Right? GM square is approximately equal to your AM into HM. So let's see whether this holds or not. This is approximate, right? Um, so let's square the GM. How much it is? 48 into 54. It's not holding good in this case, but we won't go into the mathematical relationship behind this. But usually it is said that your GM square is equal to AM into HM. Okay, so guys, we are good with our discussion today, right? We've discussed arithmetic mean, weighted mean, geometric mean, and harmonic mean. There's only one thing that we've left to, that we didn't discuss today is, I told you that for calculating harmonic mean, all observations in the distribution have to be positive. Why is this so, guys? Please tell me, why is this so? Why do all observations in the distribution need to be positive for us to calculate the harmonic mean? Guys, any idea?
So because the even level powers of negative numbers are not possible.
So let's understand this with the help of an example. Guys, calculate the harmonic mean of -1, 2 and 3. That would be 3, which are the number of observations. Reciprocal of -1, that is 1 by -1. Reciprocal of 2, that is 1 by 2. Reciprocal of 3, that is 1 by 3. Now calculate this, what do you get? Guys, how much are you getting? Jaldi bolo. 3 by
Minus
-1
18.
by 0.5 plus 0.33. कितना आया संकुश?
Minus 18.07.
-18. So guys, can the average of -1, 2 and 3 be -18? Is it making any sense? Guys, is it making any sense? Can the average of -1, 2 and 3 be -18? बोलो, हो सकता है क्या
No,
ऐसा?
sir.
Does it make sense? It does not make any sense. So you
No.
can see that the harmonic mean is negative, which does not make sense for a data set containing positive and negative numbers, right? And that is why it is generally not recommended to use the harmonic mean for a data set that contains negative values, right? So if you have a data set which has negative values, it's advisable that you use the arithmetic mean, right? Are we good here, guys?
Is there any way we can convert? Is there any way we can convert the negative to positive, just like the what we did for geometric mean?
uh, no, Victor, none that I can think of, right? None that I can think of, and none that is advised in our textbooks, right? None I can think of, and uh, no, Victor. My answer would be no to this, right?
Okay, sir.
Okay, guys, are we crystal clear with all these concepts, GM, HM, and arithmetic?